It's a warm afternoon, and you glance at the sky. The forecast says it might rain later, but who can be sure? Now imagine a world where an AI system doesn't just predict the weather, it programs it. In this scenario, storms are tamed before they land, droughts get broken up by targeted rainfall, and deserts slowly come back to life. Sound too good to be true? Today we're exploring AI-driven weather control. Could we program the climate? We'll journey through the futuristic idea of using geoengineering, supervised by artificial intelligence, to manage our planet's atmosphere. And if you find this topic as mind-bending as I do, please consider subscribing. Your support helps us keep tabs on emerging frontiers at the intersection of science and ambition. Let's be clear, messing with the weather is no trivial feat. The term geoengineering covers a broad range of proposed solutions that try to counteract climate change or extreme weather patterns. Some ideas involve brightening clouds to reflect more sunlight, injecting aerosols into the stratosphere to cool the Earth, or even deploying massive systems to alter ocean currents. In principle, advanced AI could orchestrate these approaches, constantly analyzing real-time data from satellites, weather stations, ocean buoys, and more. Through machine learning, it might decide which intervention to use and in what amount, aiming for a delicate balance where no region suffers from unintentional side effects. Think about what AI already does with weather prediction. Models like those from the European Centre for Medium-Range Weather Forecasts, or NOAA, rely on supercomputers that parse countless weather variables to forecast storms or temperature changes up to weeks in advance. Now, dial that up a notch. Instead of just predicting, the AI could direct specialized drones or airplanes to seed clouds with particles, breaking up a hurricane before it intensifies. Or imagine an AI ordering the release of reflective aerosols into a region's upper atmosphere to reduce local temperatures by a degree or two, forestalling a deadly heat wave. The technology to do smaller-scale interventions, like cloud seeding, already exists. The real leap is harnessing AI to manage this on a global level, coordinating multiple interventions and continually adjusting them based on feedback from sensors around the world. But why would we even consider such a radical step? The main driver is the acceleration of climate change. Rising sea levels threaten coastal cities, hurricanes appear to grow in intensity, heat waves break temperature records year after year, and droughts ravage farmland. Traditional climate solutions, like reducing greenhouse gas emissions, remain essential but slow to show results. Geoengineering, if managed by a well-trained AI, could theoretically offer more immediate relief, reduce the intensity of a hurricane about to smash into a coastline, or bring rain to parched regions experiencing catastrophic drought. In the best-case scenario, this could buy humanity valuable time to transition to renewable energy and more sustainable practices. Yet the idea of an AI controlling weather patterns also opens up some daunting ethical, political, and technical dilemmas. For starters, weather doesn't stop at national borders. A rainfall diverted to break a drought in one country might deprive another region of much-needed precipitation. Or perhaps the scattering of reflective particles to cool the atmosphere in one hemisphere triggers unforeseen shifts in monsoon patterns on another continent. A well-intentioned effort to mitigate local climate woes could end up causing famine or flooding somewhere else. AI, while brilliant at crunching data, might not grasp these social and moral consequences. That's why some suggest a global governance structure for geoengineering decisions. But even if we muster the political will for that, who designs the AI? Who sets its priorities? And if multiple powers compete to develop their own climate manipulation technologies, could we see weather wars, where each AI is fiddling with the atmosphere to favor its sponsor? Let's not forget the possibility of catastrophic malfunction. Weather systems are extraordinarily complex, with chaos theory illustrating how a tiny change can amplify into something huge, the old butterfly effect. Even the smartest AI might fail to anticipate an extreme feedback loop or an unexpected synergy between two interventions. We could wake up one day to find that a well-intentioned attempt to reduce global temperatures spurred a colossal storm formation. The AI might try to correct for that, triggering another chain reaction. The scenario unfolds like a science fiction nightmare, except it's real weather, affecting real people, real ecosystems. It's this unpredictability that leads many scientists to approach geoengineering with intense caution, if not outright skepticism. One of the more benign-sounding proposals is reversing desertification. The AI would identify areas where rainfall could be engineered, perhaps by increasing evaporation over nearby oceans or by cloud seeding upstream of desert zones, leading to gradual regreening. Over years or decades, we might see expansions of arable land, the return of wildlife, and carbon sequestration as new forests take root. The idea is beyond enticing. Turning deserts into farmland or forests could help feed growing populations and stabilize climate. But again, meddling with precipitation in one region can throw off water cycles in another. The question becomes, do we trust an AI to manage that level of complexity and make fair decisions about who gets the rain? There's also the matter of harnessing enough hardware to make these interventions significant on a planetary scale. Sure, smaller experiments exist, cloud seeding near ski resorts to boost snowfall, for instance. But global-scale geoengineering might require fleets of specialized aircraft, massive floating platforms in the oceans, or satellites that release reflective material. AI would coordinate these devices, deciding precisely when and where to act. The cost would be astronomical, likely running into the trillions, and the organizational challenge immense. Private corporations might get involved, eyeing not just philanthropic goals, but also profit opportunities. Could a future arise where corporations sell stable weather packages to governments? Or perhaps hold them hostage with the threat of withholding crucial interventions? Despite these concerns, the allure persists. The science behind climate engineering might be nascent, but the idea that we could buffer ourselves against catastrophic climate change is powerful. We see how quickly AI can adapt to data in other domains, like beating champion chess players or analyzing genomic information for new drug discoveries. Imagine that same computational power applied to real-time climate data, dynamically adjusting the atmosphere in a never-ending balancing act. If we're already entrusting AI to drive our cars and manage our finances, perhaps trusting it with the skies is the next leap. Yet the difference is magnitude. A glitch in your self-driving car is localized. A glitch in global weather control could ruin entire ecosystems or displace millions of people. Critics also point out the moral hazard angle. If governments and corporations believe that an AI-managed climate fix is just around the corner, it might discourage the hard but necessary work of cutting emissions and restructuring economies towards sustainable models. Why invest heavily in renewable infrastructure if you think you can flip a few weather switches 20 years from now and solve global warming symptoms? This complacency could backfire if the geoengineering approaches prove unworkable, or if their side effects are worse than the original problem. Still, some argue that even discussing geoengineering and AI-based solutions is better than ignoring them. Climate change is escalating faster than many expected. AI, for all its flaws, is undeniably potent at analyzing complex systems. Could we at least keep these tools on the table for emergency scenarios, like a series of megastorms or a sudden climate tipping point? The logic goes, better to have a partially tested geoengineering plan in place than to have no plan at all when the crisis hits. But that leads us to another question. Who decides when to activate such measures? A single nation? A global coalition? The AI developer themselves? The diplomatic and ethical ramifications multiply rapidly. Regardless of where one stands on the feasibility or wisdom of AI-driven weather control, it's hard to deny that we're edging toward a new era. Modern AI can parse through atmospheric datasets that a decade ago were beyond comprehension. It can run simulations that incorporate millions of variables: monsoons, ocean currents, greenhouse gas levels, albedo changes from melting ice, in ways that humans just can't. If climate stressors continue to worsen, public pressure for bold action might push us to test these systems in real life. It could be a grand success story or a cautionary tale in the making. In the end, the question isn't just about could we program the climate? It's about whether we should, and if so, how. Do we have the wisdom to shape planetary weather without trampling on the rights of communities who never asked for it? What about future generations that might inherit unforeseen consequences? While AI can handle the computational side, the moral and political decisions remain ours. If you find this tension compelling and want more insights into how technology intersects with global challenges, subscribe to stay informed. These conversations matter because if we do push forward with AI-driven weather control, the stakes, both for success and for failure, are unprecedented. Thanks for joining this exploration of a possibility that feels equal parts daring and daunting. As climate pressures mount, we may see more frequent calls for radical solutions. Whether AI-based geoengineering emerges as a lifesaver or a Pandora's box will depend on the precautions, the regulations, and the collective will to handle power responsibly. We've conquered mechanical flight, harnessed nuclear energy, and built global communications networks. Now the next question on humanity's horizon might be, can we and should we code the climate?